Betelgeuse is a fascinating celestial object that fascinates astronomers and astronomers alike with its impressive size and unpredictable behavior. Located in the constellation of Orion, Betelgeuse stands out as one of the most exciting stars in our sky. If Betelgeuse were placed where our Sun is, it would reach the orbit of Jupiter, emphasizing its enormous size. This red giant star is not only massive, but also very unstable and appears to be on the verge of a catastrophic explosion. The universe works in complex and often unexpected ways, and events like a supernova can dramatically change our understanding of the cosmos. The red supergiant star Betelgeuse is 764 times the size of our Sun, and its potential to go supernova at any time has attracted the attention of astronomers, including Brian Cox. The implications of such an event are profound, especially as the James Webb Space Telescope continues to capture stunning and revealing images of this star. The question remains, when will Betelgeuse go supernova and what will its effect be on Earth? Betelgeuse has a rich observational history. It shines so brightly in the night sky that ancient civilizations noticed it. Betelgeuse, located east of Orion, is the second largest star in the constellation. Its name, meaning giant's shoulder, befits its prominent position. Betelgeuse is not only one of the brightest stars in the night sky, but its unusual red hue also hints at its potential instability. Betelgeuse has been known for centuries, with the Greek scientist Ptolemy documenting its orange color. In recent years, scientists have made more detailed studies of the star, revealing its particular brightness fluctuations. With an apparent magnitude of 0.6, Betelgeuse is classified as a variable star, indicating that its brightness changes over time. The year 2019 was an important turning point in the Betelgeuse observations. During that time, the star exhibited unusual behavior, dimming significantly and reaching an apparent magnitude of about 1.6, much smaller than normal. This sudden decrease caused great interest and concern among scientists, leading to an in-depth study. Subsequent research led to a surprising conclusion. Betelgeuse could go supernova at any time. This claim, supported by evidence from the James Webb Space Telescope, attracted widespread interest and concern. Because of Betelgeuse's unusual properties, it has been classified as a supernova candidate, mainly because of its mass, which is about 15 times that of the Sun. This mass exceeds the threshold necessary for a star to go supernova. Scientists use some sophisticated instruments to gain a deeper understanding of Betelgeuse. The James Webb Space Telescope and the Gravitational Wave Laser Interferometer Observatory were particularly important in observing the star. These observations revealed strange light waves emanating from Betelgeuse and significant changes in its luminosity cycle, which are now occurring twice as fast as before. The Great Dimming Event of 2019 to 2020, during which Betelgeuse's brightness dropped to an all-time low, raised concerns of an imminent supernova. After this dimming, Betelgeuse brightened again, becoming 150% brighter than normal, and is now the seventh brightest star in the sky. This unusual increase in brightness has given rise to several theories about the cause of the Great Dimming. Betelgeuse's red glow is a sign of its status as a red supergiant nearing the end of its life. This red hue is due to the cooler surface temperature of about 3,500 Kelvin compared to the Sun's surface temperature of 5,500 Kelvin. Despite its enormous size, several theories have been proposed to explain the Great Dim. One theory supported by the Hubble Space Telescope suggests that a large amount of hot matter ejected from the surface of Betelgeuse formed a dust cloud that obscured its light. Another theory, based on observations from the Very Large Telescope in Chile, explains the dying star's surface temperature drop, unrelated to dust clouds, which could be caused by a large, temporary dark spot. The combined theory states that both the dark spot and the dust cloud contributed to the dimming. Despite these explanations, scientists continue to observe Betelgeuse's behavior using advanced tools such as the James Webb Space Telescope. Recent observations have shown that the Great Blur involved a surface mass ejection 400 billion times larger than a typical coronal mass ejection. The James Webb Space Telescope also detected invisible light waves and frequencies, providing additional information about Betelgeuse's activity. Currently, scientists predict that Betelgeuse, which is 764 times the size of the Sun, will remain bright for the foreseeable future. However, the unpredictable behavior of the star keeps experts on their toes. If Betelgeuse goes supernova, it would be the first such event seen with the naked eye since Johannes Kepler observed it in 1604. Although scientists expect a supernova to occur, the exact time is still uncertain. Betelgeuse's potential to go supernova has significant implications for our understanding of stellar evolution and stellar life cycles. As a red supergiant, Betelgeuse is nearing the end of its life, having used up the hydrogen fuel in its core and melting the now heavier elements. This process caused the star to expand to its enormous size. The exact mechanisms that cause a star to become a supernova are complex and not fully understood, but they involve the collapse of the star's core and a subsequent explosion that ejects the outer layers into space. The study of Betelgeuse offers a unique opportunity to observe these processes in real time and collect data that can help improve our models of stellar evolution. The effect of the supernova Betelgeuse on Earth is very interesting and worrying. Although Betelgeuse is approximately 640 light-years away, the supernova would still have a significant impact on our sky. Betelgeuse shone as brightly as the full moon for several weeks, perhaps even during the day. This would be an unprecedented astronomical event for modern observers. However, the distance also means that harmful effects, such as radiation, would be minimal and would not threaten life on Earth.
The main effect would be on our night sky and astronomical observations, as the intense light from the supernova can interfere with observations of other celestial bodies. The continuous observation of Betelgeuse at various observatories around the world emphasizes the importance of this star for understanding stellar phenomena. The James Webb Space Telescope, with its advanced capabilities, provided important data that helped shed light on Betelgeuse's behavior. The telescope's ability to observe infrared wavelengths allows scientists to see through clouds of dust and study processes in and around the star. This ability is particularly important for understanding mass eruptions and other phenomena observed in recent years. In addition to the James Webb Space Telescope, other observatories also play a key role in the observation of Betelgeuse. For example, the Very Large Telescope in Chile took high-resolution images of the star, allowing scientists to study its surface in detail. These observations showed that Betelgeuse has large convective cells on its surface that contribute to its variability and the formation of dust clouds. The Laser Interferometer Gravitational Wave Observatory, LIGO, also looks for gravitational waves that can be generated by the processes of Betelgeuse. These observations can provide additional information about the internal dynamics of the star and the processes leading to the supernova. The study of Betelgeuse is important not only to understand the star itself, but also because it can teach us about other stars in our galaxy. Red supergiants like Betelgeuse are relatively rare, but they play a crucial role in the chemical enrichment of the galaxy. When these stars go supernova, they eject large amounts of heavy elements into space, which are then fused into new stars and planets. This process is necessary to form the elements necessary for life. By studying Betelgeuse, scientists can better understand these processes and how they shaped the evolution of our galaxy. General interest in Betelgeuse and its possible supernova is also significant. The star's behavior was widely reported in the media and captured the imagination of people around the world. This interest provides an opportunity for science communication and education, helping to engage the public in the science of astronomy and the exploration of the universe. Events like the Betelgeuse supernova can inspire a new generation of scientists and astronomers and underscore the importance of continued investment in space exploration and observation. As we continue to observe and study Betelgeuse, new discoveries are likely to be made that will increase our understanding of this fascinating star. A combination of observations from multiple telescopes and observatories and advances in theoretical modeling are helping to solve the mysteries of Betelgeuse and its approaching supernova. The information gathered by Betelgeuse also contributes to a broader understanding of the life cycle of stars and the processes that drive their evolution. In conclusion, Betelgeuse is a star of immense scientific interest and importance. Its size, variability, and possibility of going supernova make it a unique object of study. Observations from the James Webb Space Telescope and other observatories have provided critical insights into Betelgeuse's behavior and processes. Although the exact timing of Betelgeuse's supernova remains uncertain, continued study of this star will undoubtedly contribute to our understanding of stellar evolution and the dynamic processes that shape our universe.